Yes. Welcome to 3D Printing for Social Change workshop. I am Bob Afwata. I will be your lead trainer. And as I told you, I have a background in electrical engineering, and I have been involved with technical training on a wide variety of technologies and topics such as design thinking. I have done some workshops on design thinking, electronics, and IoT. And also I've worked closely with the incubation hubs or maker places around Nairobi. It's a great honor to be your lead, your technical trainer in this 3D printing for social change workshops. So I'll just take a quick, so the rules will be, you'll unmute very quickly, and then I won't take everyone, but at least I'll try every single day to at least know each one of you. So I'll just go randomly. I'll start with Kennedy Nyosoro. Please just unmute, tell us who you are, and then we'll continue. 1 minute.
Okay, thank you so much. I'm not sure if you can hear me. Can you hear me? Okay, can't hear anything if you can hear me. Yeah, but I'm Kennedy, and I have a background in BCom, done some CPA, but I have passion in development, and that's the software developments where currently, learning and trying to practice. And so having such forums, I believe, will just help me, develop my passion. Thank you. I think, Bob, you are muted in case you are saying something.
Yes, so we will go to Gashie. Gashie, please.
Hi guys, I'm Edward. I'm Gashie. I have a background in information communication technology. I'm passionate about a couple of things. One of them is graphics designing, and I can see I was also interested in 3D printing. Yeah? And when I go to see this chance, I just hopped onto it. Thank you.
Thank you. We have a BCom guys. We have a graphics guy. Very nice. Grace Muhoro. Grace.
Hello people. Hi. I hope you can hear me.
Yes.
My
continue.
name is Grace. My name is Grace Muhoro. I am a photographer, but I also have a background in economics. Yes.
Okay. Thank you. Thank you very much, Grace. We have Ivy Vuguza. Ivy. Just taking randomly, like few people to Ivy. Ivy is not there. Rotich, please. Anastasia, I think.
Good morning, everyone. I'm Anastasia Rotich, and I have a background in computer science. And I saw the 3D opportunity, and I decided to hop on it. And I'm willing to learn more, and I get to share with you guys.
Okay, yeah. So I'll try very much everyone to ask you guys questions here and there, and so we'll get to hear from all of you. So I'll go straight to the point, to the classwork. Can you see the slides?
Yes.
Yes. So so we are going to start with the first lecture, or the first. The course is consists of 7 lectures or 7 classes. Around 3 of them are going to be theory or online on this platform on Zoom. And remember, we are having 2 sessions. We are 2 cohorts. Those who are doing the morning session from 10 a.m. every Saturday to 12 p.m. And then those who are starting from 2 to 4 p.m. So you are in the morning cohort, and I would very much like to request you to stick to your cohort. Don't go to another cohort and start asking questions which were in cohort 1, which may bring confusion to the other teams, because you may be way ahead of the others, or they may be lagging in one way or the other. So this course is brought to you by Lake Hub Foundation in collaboration with American Spaces. As I said last week, we are going to run the session to around between now and around April, when you are going to learn about 3D printing, the basics of 3D printing. We are going to learn about the tools that you require to operate a 3D printer. By tools, you are going to know when you are 3D printing, there are some tools and chemicals that you need to help you produce high quality 3D printing material or product, if you're printing a prototype. We are also going to learn how we can use 3D printing in medical to make medical equipment. I'm going to share with you some great research that are going on in the 3D printing field, and also in the biomedical field, so that you can be inspired to build your products or build your final project using 3D printer. Then we are also going to learn about troubleshooting, how to troubleshoot if you have a new printer and you are having errors. You are going to see the kind of errors that I've been having and how to troubleshoot them. So, so we are going to learn about that. And for those who don't know what a 3D printer looks like or what a 3D printer is, I have some at my background. You'll be able to see. These are the Ender 5 Pro 3D printer. We are going to get access to this, as well as other 3D printers that are out there in the market. I'm going to show you even where you can get access to them and the most common 3D printers around. Then 3D printers can print out of plastic, can print out of metal, can print out of ceramics, as we are going to see in today's lecture. But look at this. I shared some photos on WhatsApp, but these are a few things which I have been printing this week. This is a very nice part, which we are going to learn how to design, basically to draw using software, such parts. We are going to design a similar part. It may not exactly be this, but a similar thing. You can be able to see how it was designed and then designed using the software and printed. We are also going to see how to download. You can be able to download, like this is a model of a cat. You can be able to download such models. Or somebody was asking me about Blender. Yes, you can use Blender. And if you know how to model 3D objects using software such as Blender, yes, we are going to use such and download this, as long as you have the correct format, which is called STL, and then you can print such. So we are going to have a lot of fun doing this. We are also going to learn CAD software. CAD stands for Computer Aided Design. So Computer Aided Design basically is how to use a computer to aid or to help you in designing 3D objects that you can be able to print. So the curriculum which we are going to use here, we are going to share them after every class. We are going to share a PDF or a PowerPoint presentation we are going to share a PowerPoint presentation of the class. I won't share everything ahead, but I'll share with you what we have covered so far. You go through them. If you have any questions, I am on the WhatsApp group. You can text, and we can also share. So this content which we are going to share has been developed in conjunction with the 2 gentlemen who I want to give a shout out to, Mr. Andrew from Pennsylvania State University, and Professor John Gershon, who is also a professor at Pennsylvania, but also a co-founder of a company called Kijenzi. So I'm very grateful to them, and they helped us design the coursework. So the first lesson today, we are going to learn how you can be able to, you're going to learn about 3D printing, what 3D printers are all about, the anatomy. Basically, the anatomy means the structure, what consists of a 3D printer. It's pretty standard. What things like the extruder, things like the base, you are going to see what consists of a 3D printer. And also we are going to also take the real life 3D printing applications, or applications out there in the field where 3D printing is being used currently, and how you can also get involved. So 3D printing in brief. 3D printing is there are some questions here in the chat. Yes. There are those who cannot join the group, the chat, or the call. Everyone can join, right? I think that's who just are talking about WhatsApp. Okay. So 3D printing is also known as additive manufacturing. So basically what we mean by this is 3D printing is a process whereby you add material, you make your 3D object by adding material layer by layer. So you add a thin layer of material piece by piece to make the final 3D object. So if you have an example of this, which we 3D printed sometime, we made it by adding material layer by layer. You started from the bottom, you add a layer of material, in this case it's plastic, a thin layer of material, layer by layer, at a step or stepwise until you reach the top part. So it is compared with what is called subtractive manufacturing. So subtractive manufacturing is whereby instead of adding material, you subtract or you remove the material. There are processes like, or tools such as a milling machine, a CNC milling machine. In this case, it works by cutting away material. So a CNC machine, you put a block of material. It can be aluminum, it can be wood, it can be all kind of metal, and then you mill out, or you cut away the unwanted parts. So if you wanted to make such a cut, you would have such an object of a cut. You'd have a box, or it can even be a cylindrical shape, and then you'd cut away the material that you don't want. So that is what is described as subtractive process. But 3D printing, or 3D printing, is also described as additive manufacturing, meaning you add material instead of you add material instead of removing. So where in 3D object is created, you create it by a CAD software or a computer-aided design. That is how you create the 3D object. And then you send it to the printer. The printer in this case is the 3D printer, where the physical object is created by successively adding material layer by layer. I think that is very much clear. Just know it is additive manufacturing, meaning that the process works by adding material successively layer by layer, compared to other processes which removes or which cuts away material, such as CNC milling and laser cutting. So laser cutting and CNC milling are examples of subtractive processes, while 3D printing is an additive manufacturing process. So why do we really need 3D printing, or what what is the rationale behind 3D printing? 3D printing is a big business. I'm telling you that the top manufacturing companies, if you go to top aviation companies, you go to Boeing, you go to Tesla, you go to Airbus, you go to NASA, there are 3D printing parts. And we are going to see that in the applications. So it's a billion-dollar company. It's a billion-dollar process or a billion-dollar market. It's a multi-billion-dollar market that is growing rapidly, and it's expected to continue growth into the future. So according to research, according to my research also, I found out that what is fueling 3D printing is because the patents that were people who applied patents, some of the patents are just beginning to expire. Some of them have expired. So that has made 3D printing pretty much very open, and people are really using those patents to build great 3D printers. The technologies have improved, like the precision of laser, or the precision of the machines, of the motors that are used to make 3D printing has improved. So that has really spurred growth in this market. So the statistics are there. You can see it's expected around 2025. These were just projections that it will be worth around 200 to 500 billion US dollars annually. So this is not a joke. This is something which is very serious. People are using them in tools and molds. If you go to, say, you go to Airbus and or you go to Lockheed Martin, or you go to Boeing, these are companies that make planes or that are in the aerospace market. If they need to make a new wing or they need to make a new engine, then they cannot just, if they use something like CNC mill, it's very expensive because you cannot be able to be milling aluminum or steel or whichever material that they are using. It's wasteful. We are going to see some comparison, but they make something which is called a mold, which can be very complex, but with 3D printing, they can be able to do that. Then in the consumer, it's expected to be around 5 trillion market. People are making consumer products like your phone. If you go to Apple, you'll be able to see that the prototypes for the iPhone, they make them actually using some 3D printing process at one time. Then also in the product manufacturing and others like biomedical, industrial, and all that. So it's a very commercially viable product. And even locally in Kenya, even in Nairobi alone, there are a lot of interest. There are a lot of manufacturers who are showing a lot of interest in venturing into 3D printing. So you can look at that as an investment opportunity. So there is also something called injection molding, and we want to compare it with 3D printing. So 3D printing and plastic injection molding are both helpful processes. They are very useful in an industrial process or in an industry. 3D printing has given engineers the powers to create plastic designs on their desks and bring them to life in a matter of hours. So for example, you can see the 3D printer I have at my background here. It's a very small printer. It's a desktop version. So you can have this at your workplace. You can have this at home in your desk at home. You can have this in schools for those who are still in studying, in the schools, in the laboratories. So you can design a product, you can design a concept really quick within like 30 minutes, send it to this machine, and it will print it within an hour or so, even less, depending on the size of your of whatever you have designed. So this makes you be more creative. This makes you like, I saw some of you are artists, somebody has a background in art. You can be able to design something. You can sketch it, design it using the CAD software, or design it using some 3D rendering software like Blender. Send it to these machines, and within hours, you have got an idea of what your product is going to look like. But injection molding, on the other hand, you have to go, if you want quality, meaning it's something that people are already using out there in the market, or something that you can send to the market, and also you want to have that value. That is when you go to injection molding. It's commonly used to quickly and reliably produce high volume runs of complex designs. So for example, in your house, there may be some utensils or some things like buckets, things like pail and basins, cups, plastic cups and mugs. All those are made out of injection molding. How does injection molding work? Injection molding, I hope I can be able to show you. Injection molding works by a process of, there is what is called a plunger. I'll be able to show you a video of that before the session ends. And then that plunger, a plastic, like if you see the green machine there, the K1000 S6, what we have over there, there is the upper part which looks like a portion mill, or which looks like some where you pour maize or something. So up there, that is where you pour plastic pellets. Plastic pellets are just tiny plastics, which are fed into the machine. They are heated up. The plastic is heated up and it becomes molten, or it becomes liquid, more like liquid porridge. And then once you have that liquid plastic or liquid porridge-like substance, then it is filled inside the middle part, which has, you can see the middle part, which has got some green, which is also green. Then that is where your design is. Your design, there is something called a design pattern is, and that pattern is transferred onto the plastic, and then it's let to cool. And then after being let to cool, then you form your part. So it's a process which can make mass. It can be used for mass production, meaning you want 1,000, you want 2 million cups within like a week. Then you can feed it. You feed the plastic into this, then it just churns out the plastic, the plastic cups, which are ready to go to the market. 3D printing is a slow process. It's slow. It's a fast process, yes, but it cannot be used to manufacture 1,000 units at once. It can be only used to make prototypes or proof of concept. So if you compare the two, there is something called tooling cost. Tooling cost is the cost of making a tool. In this case, there's something called a mold, which is used by the molding, the injection molding. So if you want to make a mold, then you have to, usually it's done using a CNC mill, or it's milled or it's cut out of metal or wood or resin or some other material that are out there. So that cost is usually very high in injection molding. But once you design it and you mill one mold, then you can be able to make maybe even 100 units at once. So due to high cost of tooling, injection molding is economical for runs of hundreds of thousands of parts. So if you want to make a cup, for example, or you want to make a syringe for biomedical, so you can be able to, if you look at the syringe, how it is, it's made out, the inner part is made out of plastic, and a plunger, which is also plastic. Those parts you need to create a mold, and that mold will have maybe 100 syringes in one block. So for every run, you'll be able to produce 100 syringes. Making that part in the first place is very high. The cost is very high, but after you've made it, then it can be able to make at one point 100, at another point 100, even 100 units per minute. So by the end of the day, if you run your production process, or you run the machine for like one day, then you have produced almost 1 million syringes. So that is how they compare. So in the chart that we have there, there is the cost, effective cost per unit. and also the number of quantities or the quantities that are out there. So you can see that the continuous line is the injection molding, while the dotted line is the 3D printing. Price, we are talking about the cost per unit, and then we have the number of units in the x-axis. So you can see that at what this chart is saying in simple terms is, if you are using 3D printing and you want to make very small units, less than 500 units, for example, then it's cost effective, meaning you can be able to produce 500 units and using 3D printing process. But when it goes beyond 1,000, like we are talking about 1,000, 2,000, 10,000 units, then it's very much expensive. The price is expensive compared to an injection molding process. But an injection molding process, if you are making 1 unit, because to buy that injection molding machine itself, or to make also the mold that you are going to use, it's almost 10,000 US dollars. That's almost like 1 million Kenya shillings. So the initial cost is very high, but once you purchase the machine and you start making mass, you start going mass, or you do mass production, like 1,000 units, 2,000 units, then the cost will be very much reduced. The cost will be very much reduced, and it will be reduced, and then the cost, it's now justified to have that small amount of just 1 minute. Yeah, the cost will be reduced, and then it's very much justified to use injection molding process. Okay, so I have got a poll here. I have got a small question I want to ask you. So please answer it. I'll create it very quick. As I am creating that poll, is there any question? Is there anyone who wants to ask a question? Anybody with a question? Hello? Is there anyone with a question?
Hello.
Yes.
I was asking.
Yes.
For the ones who have never came across these applications, like yes. AutoCAD 360, the one which we got in our emails.
Yes.
Will we get the opportunity to be taught how to use it?
Yes. I said one thing that we are going to learn is CAD, computer aided design. So there is an intensive CAD workshop, or like a lesson around lesson 4 and 3 and 4. We are going to extensively use Fusion 360. And I encourage even if you have a background in other software, we are going to use this and take it as a challenge, so that you don't miss out.
So it will be practical and still virtual.
Yes, it will be practical. I will be designing here, and as you also design, and then after we both design, and then if there's a problem, you'll be sharing your screen, I'll be sharing my screen, and then you'll also share your design. Fusion 360 has got a cloud capability, so you can share your design there.
Okay, thank you.
Any other question?
Hello.
Yes.
Okay, me have a problem. I'm using Linux, and Fusion 360 don't have a Linux version of their softwares. They only support Mac and Windows.
Is there a way you can dual boot into Windows?
I will try.
He can try to use a VirtualBox, I think.
Yes, please
so
try
that
using
you can
virtual
run the
box.
Windows.
Yes, because let me tell you, there are other softwares. There is like one which is called OnShape. You can check out onshape.com. But I don't want you to use it because you know when you are using a different tool, then the rest of the class is using a different tool. Then when I say you like even you go through a command, you'll be lost because you are using something different. So I want everyone to be on the same page, and we still have time. We are going to do that next week and the other week. So you still have time to even go and borrow a laptop for this session, or borrow, if you can work from your office and get a computer which you are as Windows, please do so. We still have time. We are going to start doing that from next week. Okay, I want I want a question related to 3D printing. So let me ask a question then, and I will be asking.
Hello, can you hear me?
I will be asking Alex Njira, please. Can you, the others mute? Only Alex and mute. Can you just tell us what's the difference between additive manufacturing and the subtractive manufacturing?
Very quickly, additive manufacturing is where you do layer by layer, so additional. So that's what 3D printing essentially does. So you build it, whether it's plastic, metal, ceramics, it's additive in the literal sense where you do one layer by one layer. Subtractive manufacturing is, for example, the CNC milling machines. That's subtractive, where you have a big block, let's say a big block of wood or a big block of metal, then it slowly mills it and cuts it down to whatever shape and design you have. Thank you.
Very good. He has explained it very well. I'll also go through and ask Winnie Otieno. Can you, Winnie Otieno, can you explain to us what is injection molding in brief?
Hello, morning.
Yes. Morning.
According to me, I think in the way you explain it, the way I got it, is whereby you design a concept, and then after you designing a concept, and then that design you put it into that portion mill, that machine that you put on the screen, and then you print.
Then you?
And then you print that whatever you have designed, you put in that injection in that machine, and then it comes out. Like maybe you want to print a cup, you design it first and then you print it.
Okay. So I have got this video. Which I need to show you. Just 1 minute, it's loading. So I'll just mute it, but I'll share the video link so that you see. Can you be able to see my screen, YouTube, Apple?
Yes.
Yes.
So if you look at this part, what looks like a basin, you can make this out of injection molding. Things like egg trays for eggs and things like that. So how it works, this is what is referred to as a mold. If you see down there. So this is what you make, you design, you draw with software. So the middle part, that is what is called a mold. Yes, so this is what I was telling you, what looks like portion mill. Up there, that is where you pour pellets. They are like very tiny pieces of plastic. So you pour them inside there, then it gets heated up in the black part, gets heated up. And then when it gets heated up, it gets malted to be in liquid form. From the solid plastic, it becomes liquid, more or less like porridge. And then it's being pumped into the rectangular closed chamber. So that is the plastic pellets being poured inside there. Then the black parts are heating elements. They are just like coil, just like the coil that you use. And then you can see that plunger or that it rotates to make sure that the plastic is uniform. It's rotated to make sure that the plastic is uniform, like it's being stirred to ensure that the plastic is uniform. And then it's being pumped into the enclosure or the chamber there. Can be able to see. And then once it is pumped, then because you are having a pattern which is called the mold, then it's allowed to form inside that pattern. And then your part, this case, it's your basin, your cup, it cools and it's dropped off. So the middle part, that is what is called a mold. Those two metal parts, the one the one moving away and the one moving towards the one moving away and the one moving towards that is what is called a mold. So it gets filled inside there, and then the plastic or your part get dropped down there. It cools and it gets dropped. Is that much clearer? Is it much clearer now what molding is?
Oh, yes, it is, Jacob.
Yes, yes. So,
it is, but I have a question.
Yes, ask a question.
Once my question is that do you need to have a specific printer for a specific design, this machine, or is it that you are able to replace that mold there for each kind of design you want? Because it seems like the shape that is the mold looks like it's the basin you had earlier shown us. So is it adjustable, or are you able to change that mold in that machine?
Yes.
Or once you buy a mold with a specific machine, that.
Yes. So if you are making different things, if today you are making a basin, you will change that part. If tomorrow you are making a cup, the next day you are making some other thing, so that mold is what you change. Are we together? That mold is what.
So the mold is also designed.
Yes, it's what you design and then you change in that machine. Okay. And
how do you print the mold? Using you use a 3D printer to print the mold, or?
Yes. So the mold you can use a 3D printer to make, or something called a CNC. A CNC, I told you, is a milling machine, which in industries, you go to industries like Ken Poly, the guys making basins, cups, if you see most of the plastic you have in your house, pail, they are made out of there is Ken Poly. So they have various molds for various types of plastic, cups, plates, and all that. So they just keep on changing them. If they want to make plastic cups, they put the plastic cups one. Is that clear? There are two people who have raised their hand.
That's clear.
Yeah. So anyone with a question? Those who have raised their hands?
Hello?
Yes.
Does the machine come with the mold part? You buy the mold separately with the machine.
You make the mold separately. You make it by your engineers or your guys designing it using software such as Fusion 360 or SolidWorks and all that. And then they mill, they send it to, if you have a mill in-house or if you send it to a milling factory, they mill it for you, and then you get that mold which you use for that machine. But you can also 3D print it. There are big 3D printing machines which you can use to 3D print. Is that okay? Is it okay, everyone?
Yes, it's much okay, Bob. I
Yes,
just
it's
wanted,
okay.
Yes, yes, yes.
I just wanted to say
Okay.
that I have worked with that machine at a butter shoe company.
Yes.
Whatever you're explaining is very much in order.
Yes.
Yeah, the production is very much high with the injection molding.
Yes. Yeah. Thank you very much. Maybe one time you can help us. You can give us a tour of that place when we get time. Yes.
Yeah, I think they have educational tours as long as you let them know in advance.
Yeah. Yeah.
But I cannot promise to be the one who is taking you there unless you do that yourself, or maybe you can send me as your emissary. I can go there and try to talk with them.
Yes, we can talk about that after the event. Those who are interested, you want to see how injection molding works. I have seen it in myself, but for those who are interested, we can go on. So so we want to take you through.
Before we begin, can I ask a question?
Yes.
The pallets.
Yes.
Plastic pallets. Do they have
Yes.
to be of a particular make brand, or can you use any recyclable material also as a plastic, as part of the pellets that are put into the?
You can use any plastic material, okay? But you know, these materials are being treated. They are being treated. You cannot just take plastic like in your house and then you feed it there. It will because the plastic in your house maybe has there's something which has happened to it and all that. So you have to take that. They are special. They're just normal plastic, but they have been treated by some chemicals. They have been hardened. They have been made in. Their properties have been changed so that they can melt easily, and they can coalesce. When they are in that machine, they get stuck. They form that part easily. So it's not very much different. You can try with this other. You can try with even plastics in your house, like you have plastic Coca-Cola bottles. You try to recycle them, but the quality will not be great than the ones which you buy. Okay, those ones have been chemically treated.
So I have a question.
Yes.
Where do you get the plastic pallets? Where do you buy them?
Well, you can buy them locally. There are sources where you can get them, but mostly also you can import them. So I don't know why you're asking about injection molding. It's not our focus though, but you can get them locally, and you can also. There are those who I think are interested in even making their own. Some people I think have already seen a business idea there of making their own. But mostly if you go to places like Ken Poly or even Bata, the guy was telling me from Bata, then I think they have their own in-house process of making, or even they import from some third-party supplier. But remember that injection molding is not our key. We were just comparing injection molding with 3D printing. And if you want to use 3D printing, I'm going to share with you some 3 places where you can get plastic for 3D printing. But yes, it's not our main focus to discuss injection molding, but we were comparing injection molding with 3D printing and how it's efficient in producing mass, or like producing several units, 1,000 units within like a day or so. So there is this chart here. Just a minute. There's this chart here which explains those various types of 3D printing or additive manufacturing processes that are out there. So 3D printing is classified into various types depending on the kind of material that they are using, the kind of material, be it metal, be it ceramics, be it plastic. There's even 3D printing that prints on food, can be able to print cake or food or resin and things like that. So so one is they are classified according to how the type of material it's using. Then two, they are also classified according to how the material is dispensed, or meaning how the material is gets extracted, and it gets like how that process is forming the material is dispensed and all that. So some are not very common, even locally, because they are used by high advanced companies out there. But the main one which we are going to talk about is what is called FDM, or fused deposition modeling. The middle one, which is having a red, which is cycled in red. But the ones which are out there, there is material jetting. Material jetting, just as its name is, it's jetting material, meaning the material is coming out. There is a nozzle, or there's a very tiny hole, and the material is being dispensed in form of a jet, or like there's a jet of material. Think of it like the same way your paper printer is working. Those ones are also made in that way. Then there is binder jetting. We are going to see that. There is powder bed fusion. Powder bed is whereby there is a bed, or there is just a container in the bottom, and that container has got a powder of the material. I told you that the type of material matters. There is a plastic, there is metal, and then the form also is important. Is it coming in form of powder, or is it coming in form of like a string of material, or a roll of material, like we are going to see? So let's go straight to the examples. So the first kind of 3D printing is called stereolithography 3D printer, or just in short, SLA. Just in short, just know it is SLA 3D printer. Stereolithography is actually a chemical process. Before even we go to 3D printing, stereolithography is whereby you are using light. The light can be a form of UV light, or ultraviolet light, or what is called laser. And then this laser light source, when it hits onto a material, this material is a polymer. In this case, there is one very common one, which is called resin. Then that material, it gets heated, it gets hardened up. It turns from liquid form to solid form, or it gets hardened up. So that is the process of stereolithography. So how is it used in 3D printing? I want to show you a video here very quickly. Can you be able to see that?
Yes.
We can see it.
Yes, so I'll also share this video at the end of the lesson, but this is how it works. It's a very short video. So the first step, you've seen that he has explained have you been able to see that?
Yes.
Hello?
Yes.
Yes, you are able.
Yeah.
Yes. So basically what it happens is there is what is called a resin. I'll just explain as the video is going. So there is a resin which is in liquid form. So it's being lowered. There is a bed which is being lowered, and on that bed, that is where you are going to print your part. And you cure, the light source is brought from behind or from below. And then the basic is that the light hardens the liquid, it hardens the liquid resin, or it converts it from liquid to solid form. And then the part is formed. So you can be able to see. So the light source is guided by this, it's some advanced, think of them like lenses, or they're like mirrors which guide the light source. And then, so the light comes from bottom. You can be able to see from the bottom, the shiny part or the bright parts at the bottom. And then it hardens the liquid. The liquid is in a bath or is in like some form of a basin. And then these parts are hardened, and then your part is formed. So after hardening each layer, then the bed or where you are printing on gets raised up, and then you pour a new resin. Then after pouring a new resin, you harden it again using that laser, and then as you do it that consecutively or successively, then you form your 3D part. So that is what SLA or stereolithography is. So in short, stereolithography belongs to a family of additive techniques known as VAT photopolymerization. Just know that it comes from the word photo, which means light. And then polymer is a form of plastic. So these are forms of plastic which, when they get heated up, which when they get access to light, or when you shine a light source to them, it changes its form from liquid form to solid form. So that is what is used here. So a light source, these machines are built around the same principle using a light source, in this case, a laser or a projector, to cure. So the process of hardening the liquid to form a solid is what is called curing. So you cure the the liquid resin to form a hardened plastic. So the main physical differentiation lies in the arrangement of the core components, such as the light source, the build platform, and the resin tank. Like what we are having there, at the bottom, that is what is called a resin tank. At the bottom there, the resin tank, meaning it's just a tank where you pour the resin. The resin comes from a cartridge or just a container at the bottom, and then fills that resin tank. Then the light source is brought from below, and then the build platform, you can see there are those white plastic there. Those are what has been 3D printed. So the build platform in this case is coming from the top, or is coming from the top as it is rising up. So that is what is called SLA. Is there any question before we continue? Like how it works? Anyone with a question of how it works?
Yes, Bob, I have a question.
Yes.
You said in 3D we do a layer by layer addition. Is this
Yes.
also using the same criteria?
What? SLA?
Yeah.
Yes, SLA also
Because
works
as I
in the same criteria,
sorry.
yes.
Okay.
So you can see, let's say you want to print this, then you lower the bed from the top. Then as you lower it from the top, then at the bottom is where you cure. So in this case, you are curing from the bottom, one layer and upon one layer as you bring this on top. So that is how SLA works. Okay. The next is called binder jetting. So from the word binder, to bind something basically just means you have two solids and you want to bring them together. That is what is called binding. So in this case, I'll also share with you a short video of how binder jetting works, because so I'll just explain that. So I know some of you have seen how construction works. For example, if you pour a sand and then you have a cement, if you have cement, you like pour sand and then like on a wall, and then you pour cement which has been stirred with water. What happens is the cement will when it mixed with the sand, then it gets hardened, or the sand cannot be able to scatter away. So that is the same way. So in this case, the cement is like the binding material. So you first of all, the first step is you pour a liquid, you pour a grain size. It's a very tiny, Let me just show you that. So at this point, the first head, it moves from left to right or right to center. And then you can be able to see that it is depositing very tiny, this grain size. This is like the sand which I'm talking about. So there's the size of the sand. So each one of them is placed above each other like 2 layers of very tiny particles, which are just the size of sand particles. So after doing this, then that is put by a head which is moving on the platform, which is moving from left, right, and then the next is the recoating or placing the binding material. In this case, something like think of it something like cement. Which cement, when you pour it, liquid cement or cement mixed with water, when you pour it on top of sand, then the sand cannot be able to scatter away because the sand particles will be binded together, or they will be brought together by the liquid cement. So you can see there the white circular parts, so the white balls there, they represent the original material which you want to print from, something like sand. They are just the size of sand. They are very tiny. Then the green material, which is poured in the second round or in the second layer, is the binding material. So when they are brought together, then it binds the balls or the spherical balls together to form the hard part, so that the pattern is formed. So that is how basically your pattern or your object is formed. And remember, this is an additive material. This is an additive process also, because you are adding material. You are adding the white material, and then you are following also with adding a layer of the green material, which is the binding material, to form your 3D object. So the next one, I'll take questions once we're done. So the binder jet is an additive manufacturing process. It uses an industrial print head, which selectively, so we are not depositing the material all over, but we are only depositing it where you wanted to print your part. For example, if you want to print a house, a model of a house, for example, the bottom, only where the walls are, or only where the windows are, that is where you are going to deposit your material. So it's deposited selectively. So you deposit the liquid binding agent onto a thin layer of powder. So the first stage is you deposit a thin layer of powder, just the size of grains of sand. This can print out of metal, sand, ceramics, and also some composites. So you deposit a thin layer of this powdered metal or powdered sand or ceramics. Then you deposit the binding material on top to build a high value and one of a kind parts and tooling. The process is repeated layer by layer. Remember, the first round, there is a layer which is formed. The second round, a new layer is formed using the map. So the map is basically your design, the digital design file which you have created until the object is completed. So you get your design, which you get from your software. So that design is what is creating for you a map of where you are going to place the binding material. So the binding material is placed on the second, by the second print head, which forms, which binds, or which puts together the powdered material. And then that is continually done to form your 3D object. So remember, just know in short that the binder jet, it uses a binding material or a binding liquid, which brings together very thin layers of the particles. So it binds or puts together very thin particles of the material. The next is what is called SLM. This is this is majorly used by if you are doing metal 3D printing. Remember, 3D printing can also work on metal. So it uses what is called selective laser melting. I'll also show you how this also works. So selective laser is whereby you are going to use a laser or a very I will share with you all these videos sources. So can you guys hear me? Are you guys together?
Yes, Bob, I can hear you.
Yes.
Yes. Yes.
Okay. So
yes.
SLM, yes. So SLM is whereby you are going to use a laser. A laser is just a source of light that can, it's very intense. It's actually, it can even burn, it can even cut metal, it can even melt metal. It's a very highly concentrated source of light. So laser, if you heard of laser cutters, they're very sharp or focused light, which if you put it on any material, it can melt plastic, it can melt and even cut metal, cut ceramics, cut a lot of material. So this is what is used in this case to melt a powder of the material. And you will see how it's done. The first case is it's very similar to in a way with the binder jetting, but in this case we are using the laser to melt the powder. So what is burning there is the laser. So, and the bottom, the white part, is actually gray. That is powder metal, something like steel powder in powder form. So, or iron in powder form, very, very tiny powders. Then what is burning there from the top is a laser source, or is a source of laser light. And then the source of laser light, as it moves according to your pattern, it melts and brings the parts together. The particles or the powder, it brings them together by melting them. And then during that, it no longer becomes a powder, but it forms the 3D, or it forms a layer of your part. So you can see you can see the blue parts. The blue parts are the parts which have not been burnt or which have not been molten. They are just the material. But then the gray part consists of the part which has been hardened. It was in powder form. Think of it like you are having a powder flour of the material. And then once you burn them with the laser, then it becomes hardened. So the gray parts, if you can see, they're like three gray parts, the 1, 2, and 3, the 3 gray parts, those ones have been hardened. And then once you harden them, then you can see this moving head, the blue part at the top. The blue part is depositing a very thin layer. You can see the blue material which is being added is a thin layer of that powder. In this case, we are talking about metal powder or ceramic powder. So the head, the printing head, or the head there deposits, or it adds a new layer. So you burn a layer. After you've burnt a layer, then you add a new layer of that material. Yes, you can see there the red line there represents the laser or the heating head of the laser. So the heating head of the laser, it's very hot. As I told you, that laser can burn or can melt metal. So it's going to go to the gray part. The gray part is your part which has been formed, which has been converted from the powder into a solid part. So it melts a new layer of the material added. You add a layer, it's like adding a layer of flour, and then you melt it with the head or the laser head. So that is the head adding, it's adding a new layer. Then I want you to see there, the gray part, the gray material which is peeling away, that is the powder which was placed on the bed. And then as we push it upwards, then remember the parts which have hardened. The parts which have hardened, it's like having a cup inside the flour. Think of it like if you take a cup and then you bury that cup inside the flour or inside the sand. So when the sand is moved up, or if the container is moved up, then the hardened part, it peels off, or it more or less separates from, there is the powder, which is in this case the powder of the metal, and then there is your liquid, there is your hardened parts which have been melted together. That forms your 3D object. So you can see what's happening there. You can see what's happening here. This is the part which we have formed. There is the powder which is which has not been, the parts which have not been hardened or which have not been melted, but there is the material. In this case, it's something which looks like a gear or a fan of a machine. So this one has been hardened, or it has been molded layer by layer to form the 3D part. So that person is just sucking the excess material. Yes, and as you can see, it can be used to make very complicated or very interesting designs. And it can also work out of various forms of material, from aluminum to titanium. Titanium is one of the hardest metals out there. And the parts like engine parts of a vehicle, of a vehicle, or of an aerospace or an aeroplane, this can be able to do. Yes, so that is what SLM 3D printer is. It works very well with the metal. Just know in short, it uses a laser to harden the material or to molten the powdered material to form your 3D object. Yeah, then the most common one which we are going to use is what is called fusion deposition modeling. This is the one which even I have at my back here. Most of you are going to see it in action. All of you are going to see it in action when you come physically. This is what you will find out there. So it uses a filament, something which is called a filament. One minute. So this is what is called a filament. Can you all see it?
Yes, we can, Bob.
Yes.
Yes. Yes. So the filament, or a filament is just, this is plastic, which has been made in the form of a strand. It's a strand of plastic. They come in various thickness, or the diameter is different. Like this is like 3 millimeters. So this is what is fed into the machine. Remember the other cases we were dealing with liquid for SLA, then for fusion for SLA, for SLM, and binder jet, we were using the material in terms of powder. But in this case, it's a solid. It's a strand, or it's like a string of the material. And then this is what is fed into something which is called an extruder. So if you look there, that is how, before we go to the types of, type of filaments, I just want to show you. So the filament is the red part, which is inside there. It's this material over here. It is fed into something called an extruder or a filament driver. So inside that extruder, you are going to have a heating element, or it's just something which heats the plastic. So it heats the plastic, it melts the plastic. The plastic changes its form from the solid. If you see here, it's solid. But then what oozes out of something called a nozzle, or a heated nozzle, you can see down there, is what is in liquid form. So that is what is deposited on a build platform. If you look here, there is a build platform. It's slightly away. 1 minute. Okay, I am looking at myself too. So if you look here, there is what is called a platform. This platform is where you are going to have your build process happens. Let me just bring my computer closer. So there is a platform here. This is where you are going to print onto. It's just a base here. And then there is something called the extruder on the head. This extruder moves with the X, Y, Z axis. So this is the extruder. And then on the left, on the side, there is the filament which is fed into the machine. So you bring the filament in, there's a motor that rotates the filament and brings it in. And then on the filament, on the extruder part, there is a heating filament, that's some coil of wire, just the same like the one you have in your So this,
Bob,
yes, yes.
Bob, we cannot hear you now. I think when you're moving around, the mic is not picking up your sound.
Okay, can you hear me now?
Yes, yes.
Okay, sorry, it was away from. Okay, so I'm saying there is a bed or a platform where your part gets deposited. Then on the top part, there is what is called an extruder. So the extruder consists of a filament, which heats up the material and melts it from the solid to liquid. So we are going to see it in action, but that is basically how it looks like. And you'll see it in action or when we go to the practical part, when it's printing. So yeah, so if you see there, there are various types of filaments, but let me explain this better. The most common type of 3D printing is 3D printers are called diffused deposition or FDM printer. So this feeds a spool of filament. I have shown you, this is how a filament looks like. There are usually two types, PLA and ABS. It is fed into a heated nozzle. So it's a heated nozzle which consists of just an element. Just think of it like a coil. It's just a coil of wire which when you feed electricity to it, it gets hot. And then when it gets hot, then it melts the plastic. In this case, it's what's called PLA and ABS. And then it melts it to form a liquid. So the liquid is what is put layer by layer. I think I shared a video of how the printing happens, but I can share another one again. I'll share with you on the WhatsApp group so that you see how the layer is placed layer upon layer of the material. The layers cool, and then they harden to form your 3D part. In this case, it's a model of an elephant that you can see. Then there are two types of filaments that are out there. I'm just looking at time. It's 11:29, so that we don't get late. So the types of filaments that are there are two main types. There is PLA and ABS. So somebody was asking me, where do we get these plastics? We source them. They are like some 3D printing houses or some companies. There is one called Nerocast, which is in Thika. There is also another one called Pixel Electric. There is also, you can basically even just order them online. You buy them from AliExpress or Amazon, from whichever part you order things, you can buy them online. But locally, there are a few places which I know, which sells this. A big shout out to Nerocast. There is also Pixel Electric. There is also a company that actually sells 3D printers. I'm forgetting their name. I'll share with you their name. They also sell the 3D printing plastic, or what is called the filament. So what is PLA? PLA in short is, it's a short form of something called polylactic acid filament. It's very common. Even what I am having here is PLA, or is PLA type. They are cheap, or they are low cost compared to the others. They are low cost effective prototyping material. So what I have here, it's not ideal for making a final product which you can sell to someone in the market there. You can use it for making a prototype. meaning a proof of concept product. You want to see how the look and feel of your product will look like. PLA is biodegradable through a process called industrial compositing, and it's made of renewable materials such as cornstarch and tapioca. So it's there's just some materials that are out there. It's basically made out of starch, which is found from corn or maize. Just think of, they get starch from maize and then they mix them with other materials to form this element. So it's, in a way, it's more friendly to the environment. It's biodegradable. You can be able to, your part, once you produce it, you can take it through an industrial process to break it down. However, the other one, which is called ABS, it's more rigid or it's stronger, then it is prone to breakage, meaning if you print your part from ABS, it will break easily. It's not very flexible. It will, you apply some stress to it or some force to it, then it will break easily. So ABS in form is acrylonitrile butadiene styrene. It's some it's basically some chemical composition. It's very strong, flexible plastic. It is also recyclable, but it will give off potentially hazardous fumes, and adequate ventilation is usually needed for supply purposes. For safety purposes, is essential. So just know that ABS is very dangerous. When you are using an ABS printer, it produces some fumes or some gases as it burns. It's not very friendly to the environment because those gases can cause cancer or some breathing problems. But the upside down, the upside part to it, it's much stronger and also much flexible. So if you are doing, if you have a notebook, you can do a table on one side, ABS, PLA. PLA, you say, is cost-effective, popular, and very common. PLA is biodegradable, while ABS on the other side is stronger, is recyclable, but also it gives hazardous fumes, meaning it's not very good for, like when you are printing out of ABS, then you need to have good ventilation for your safety. So those we are going to find out. So this is how they look. There are other types of filament that are out there: Petg, nylon, TPU, PVA, and PC. So these are other types, and they vary depending on their flexibility. How easy is it to bend? So if you've seen a bottle of soda, the plastic, I happen to have one here. So if you look at this material, you know, it can be bent. You can be able to bend it. So this is what is called Petg. So it's a plastic which can bend. If you look at the soda plastic bottle, the plastic soda bottles, that is the material. It's fairly, or it's flexible and also very strong. Then nylon, nylon is used on some. There are some nylon clothes or some nylon parts of clothes or things like that. It's also very strong, flexible, and durable. TPU is flexible like rubber. You've seen the rubber bands which people wear on their wrist. I happen to have one, but it's not around. I'll show you. So it's that material used to make the rubber bands which people wear on their wrist and all that. Then also PVA. PVA in this case, if you are taking short notes, it's water soluble. So we are going to see one of them. Samuel, please mute. Thank you. So PVA is water soluble. So it's a plastic which when you put it in water, it dissolves. And we are going to see it in our lab. There is a printer that uses it. It's used, if you're taking notes, short notes, it's used for what is called printing, what is called support material. So support material, we are going to see if you are printing these complex shapes, then you need to print some excess plastic on the sides to support it, so that, like, if you see the tail of that dog, or the horn of, if you are printing a model of a cow, the horns and all that, for you to print it well, then you need to print some support material below those. So we are going to see how they are used. Then the last one is PC, which is also strong, flexible, durable, and heat resistant, meaning it does not burn very easily, or when you apply a lot of heat, if you put it in the sun, it will not be affected by heat. So, then we before we go to printer anatomy, I just have some few questions which I want to ask, and I'll be asking attendees. So 1 minute. I think it's Ian Matthew. It's Ian. Hello. Can you explain to me can you name the types of 3D printers that you have? I think it's Ian Matthew. Yes.
Yes, Bob. My name is Imanthu.
Okay, Imanthu.
Yes. So I think we have the most common one is the one that you explained, is the FDM, the fused deposition modeling. Then we have the selective laser melting. There's also the binder jetting and the stereolithography.
Yes, thank you. Yes, mentioned very well. There are the 4 types. FDM is the most common one, which uses filament. It's the one which we are going to use. You've seen it. Then there is SLM, selective laser melting. It's used on metal, ceramics, and all that, even plastics. Then we have binder jetting, and then the stereolithography, or what is called SLA printers. Haya, mtu mwingine hapa. Nick, can you explain to us how SLA printers work? Nick, are you there?
Yes, I'm there.
Yes, can you explain to us how stereolithography works? Printer.
The printer, I think the stereolithography, it's a 3D printing used in creating prototypes in protochemicals processes by which
just explain what is SLA process.
The SLA process.
Yes.
I think is the process by which the object created in layer by layer using ultraviolet laser beam.
Using ultraviolet laser, okay. Who can add something? Nora, we have Nora.
By use of liquid form, in a liquid form, right?
Yes, so you have liquid, what is called resin, and it is cured. You say you cure it by using a source of light, which is called laser.
Laser beam.
Ultraviolet light or UV light, sorry, not laser. Nora, unaweza ongezea? Share around.
Yes, I'm around. Can you hear me?
Yes.
Okay, let me explain how I understood it. It works by a high-powered laser to harden liquid resin.
Yes.
Also, it contains a reservoir to create a 3D shape.
Yes. Yeah. Thank you. So there is a reservoir.
That is what I understand.
Yes. Thank you. So there is a reservoir at the bottom, and that reservoir contains the liquid resin. And this liquid resin it's photosensitive, or what happens is when it interacts with the light, then the liquid is hardened, or it's cured. You say it's cured. So the light source is directed and it cures the material there, hardens it, and after hardening it, it forms a layer of the 3D part. Then the platform where you are printing on, it moves up. After moving up, and then a new layer is created. That happens continuously until you form your part. So Frank Omolo, can you explain to us how binder jet works? Frank, are you there?
Yes, I'm here. Can you hear me?
Yes.
Okay, so how I understood binder jetting is basically the technology, or in some cases it's referred to as binder bed and inkjet, whatever. It's a rapid, it's that kind of a 3D printing where we use the raw materials, or rather powdered form materials, into printing models and are binded by some other sort of material. Basically, that's what I understood about binder jetting.
Yes. Zipporah, can you add something? Zipporah Mbai, I think. Thank you, Frank. Is she there? Sophia, can you hear me?
Yeah, I can hear you.
Yes, can you add something?
Okay. What I got is that in binder jetting, you like a thin layer of powder is first deposited, and then after which the liquid binding agent is then also deposited. The process is repeated layer by layer until the whole 3D model is formed.
Yes. So you have thank you. So you have a powder, a thin powder of the material is deposited first, and then like 2 layers of or 2 fine particles. Then a binding agent or a binding material is added. The binding material adds, when the binding material is added together, it forms a solid part, which brings together the parts. And then after bringing together the part, it's hardened, or the part is formed from there. You could be able to see from the video. So I'll be able to. Oh, Zipporah had a problem with her mic. It's okay. Arwa, can you explain to us the FDM, fusion deposited? FDM is the last one which we explained. Arwa, can you hear us? ASCII, okay. Who is Griffin? Griffins? Guys, please, if you are in this call, you have to participate. If you don't know, you just say, sorry, I didn't get that. So that we don't have people who join and then they just let the laptop stay there and they are doing their own thing. Griffins, are you there? He's not there. Okay. Eugene? Eugene?
Yes.
Yes, Eugene, please explain to us FDM, the last one we explained.
So the fuel deposition modeling.
Yes.
Yeah, what I got to the fuel deposition modeling is we use a filament kind of a material. Yeah, so which is being put into a machine and then hardened into a model. Yeah. There are various types of the most common types of FDM that are being used are the PLA and the ABS. This is the polylactic acid filaments, which is commonly used and cost effective, and the acrylonitrile butadiene styrene is strong
ABS.
and flexible.
Okay.
Yeah, ABS.
Yes,
Yeah.
Thank you. So, in short, it uses a filament of material. There are other people who are having problems with their internet. Sorry, you can get stronger internet source and next time. So ABS, yes, explained how FDM works. So you have a filament and the filament is fed into what is called an extruder. The extruder consists of a heating filament which melts the plastic, and then the plastic is deposited on the platform or on the bed layer by layer, and that happens successively to form your 3D part. So I'll go to Jefflin Atieno. Can you tell us the difference between ABS and PLA? Just quick.
Can you hear me?
Yes.
Can you hear me?
Yes.
ABS is rigid, and it is also packaged.
And it's also?
Unlike PLAs, and it is strong to breakage because it is not flexible. Unlike PLAs, which are cost-effective prototyping materials, which are biodegradable.
Okay. Yeah, so ABS is much.
And they are made from starch.
Yes. So PLA is made out of starch, corn starch. You can just mute when you are Griffins, please mute. So PLA is made out of starch. It's much flexible. Somebody is having problems with my
Samuel mute. Samuel mute.
Please mute. Okay. So PLA is much flexible. It's made out of starch, and then it's low cost, or it's cost effective to use. While ABS is much stronger. And also it's more or less brittle, or like it's strong. So if you apply some force to it, it will break easily. And also burning ABS produces some fumes or some smoke, which is not good. So you need some good ventilation when you're using that type of printer. Okay, so let's continue. We have almost how many minutes to go? We have like 9 minutes to go. So because we are ending at immediately 12, so that we have the next team. So there is what is called the anatomy. The anatomy is just the various parts of the 3D printer. And the type of 3D printer which I said we are going to focus on is FDM, or fused deposition modeling. So it consists of 4 parts. There is the mechanical structure or the mechanical architecture. There's the extruder, the bed or the platform, and the leveling mechanism. Then there is the electronics and control board. So in short, if you have a printer, then there are various parts of a printer. Just like your phone or your device has got various parts, the printer also has various parts. So the first part is the mechanical architecture, or the mechanical part. So if you look at the printer here that we have over here, there is the mechanical part. Just 1 minute. So there is the mechanical part. There is this, it's made out of extruded aluminum, which forms just the case, or forms the body of the printer. So there is this 4 part. There is this aluminum parts. They form the case, or they form like a housing for the printer. Then there is the extruder, which is on top here. You'll see how it works. We are going to go deep into it. Then there is a base. The base is where the printing works, or that is where the printing goes on. So let me just set this to print something. So I've set it to print something, and you'll be able to see when it's printing. So this is the base where it's going to print. And then there is a bed. This base has got a leveling mechanism. There are some springs at the bottom which you rotate, and as you rotate it, you can be able to set the base properly, or so that it can print well. Then they will first start with the mechanical architecture. So the mechanical architecture, how it works is there are 2 types of mechanical architectures. There is one which is called Cartesian. If you remember your maths, Cartesian coordinates, the X, Y, and Z coordinates. So it's this type that we have here. So it basically has got an X and an X, and X is this side from left to right. This is the X-axis. Generally, this is the X-axis from left to right, like that. And then there is a Y. Y is from this side going inwards. That is the Y-axis. And then the Z-axis is from top to bottom. So basically, it's just like a box. And then if you have a box, there's the length, there's the width, and then there is the height. So one like the length from this side left to right, like that, that makes up the X-axis. Then from one end to the other one, to the bottom or inwards, that forms the Y-axis. And then the Z-axis is from top to bottom. So you'll see the printer, it's labeled X, Y, and Z. So those are the 3 axes. So this is a Cartesian, printer. But there is the third one, which is called, there's a second one, which is called a delta. So the delta one has got the Z-axis. The Z-axis here, which is from top to bottom. You can see in the image, there is the three parts, the 3 circular parts. Those makes up the Z-axis. So when they move up and down, that forms up the Z-axis. But then the base where you are printing onto is not actually rectangular in shape, but it is circular. So you'll see that the part, the extruder is the gray part which has got an arrow emerging from it. So that can rotate on the, it can rotate in a circular part. So let me just show you a quick video. And just go to YouTube really quick and show you. So the delta has got the base in a circular form, or it's round. So this is one by this guy's one Delta Wasp 2040. It's an example. So you can see from there, we are having the extruder, where the plastic is emerging from is that middle part, the middle black part. Yes, that is the extruder. And then it moves in circular motion. It does not move in straight, it does not move in X, Y coordinates. So okay, so you see what that guy is doing is loading the filament. The filament is the blue piece of plastic strand that is coming in. So what is feeding it into is this is what is called the filament. As you can see, the plastic, it was solid form, but now it is oozing, or it's coming out in form of plastic. And then you can see it's rotating, or it's moving in a circular manner as it's moving around that bed, and it's printing. Yeah, that is how it's printing. So you can see the bed is